This might be a bit challenging to see. I'm going to give it a shot anyway. Let me know if you need me to zoom in and I'll do it again. Problem 51, we're trying to find the limit as x approaches 1. So as x approaches 1 from both the left and the right, we see the y values are getting closer and closer to 3. So the limit is 3. Okay, that's it. The limit is 3. Problem 52, where's that? Limit as x approaches 2, so as x is approaching 2 from both sides, the y values are coming right down here, approaching 2. I was looking at this one here. The limit is 2 because as x gets closer and closer to 2, the y values get closer and closer to 2 as well. And if you let your algebra eyes get in the way, then you were looking at what happens when x gets to 2. But anyway, the limit is 2. Okay, I drew this purple line right here where we can't tell what goes on at 2, and so basically I'm blinding your algebra eyes and opening your calculus eyes so you can see the y values are getting closer to 2 regardless of what happens at 2. So that was 52. 53 is a different story. As x gets closer and closer to 3 from the right, the y values are getting closer and closer to 5. So that's different than as x gets closer and closer to 3 from the left, the y values are getting closer and closer to 3. And so we can see from the right and left hand limits are not equal, so therefore this limit does not exist. Okay, the right and left hand limits exist, but the limit from both sides does not exist. Graph the function, use the graph. Okay, so when x is less than 0, we see that we have a y-intercept of -3, and we have a slope of 1. So to the left of 0, the graph looks like that. To the right of 0, it says f of x equals 2x minus 3. Well, for x to be greater than or equal to 0, we know that we can fill in that circle because when we replace x with 0, we see the f of 0 is -3, so that fills that in. It's got a slope of 2. And so we see that as x gets closer and closer to 0, the y values are approaching the same number, and that same number is -3. So -3 is the limit. Okay, 55. So I'm going to pause the video. I'm going to plug this into my y1. So maybe while I'm doing that, you guys can plug that function into your y1. Again, what we want here is we want the limit as x approaches 1. So let me circle that again so I don't cover up the 1. So that's your y1. And then we're going to approach 1 and see if we have a limit. Okay. So I went ahead and I typed in my y1, and then I hit the following keystrokes. Second table set. Then when it prompts you to input the table start, you'd input 0.99. The change in table, input 0.001. So basically what that means is we're starting at 0.99, just to the left of 1, and then we're going to adjust the table every 0.001, and then second table will actually allow us to see the table, and then we could clearly see that when you get down to the 0.999 part, so I'll put that over here, 0.999, that's for x, then the y value is 2.002, and then there's an error. When x is equal to 1, you have an error because x is not allowed to equal 1 because you can't divide by 0. And then when you get to the 1.001, you see that the y value is 1.998. At least that's what my calculator says. So we should be clear in saying that the y values are approaching 2 as x is approaching 1. So we say the limit is 2. And that's it. So reading a table is important. We have to be able to do that. All right. How much time do we have left? Oh, we're still looking pretty good. For number 56, here we're not looking at a graph. Finally, we're just looking at a function, we have a constant. The limit of a constant is always the constant. So negative 5 is the answer for number 56. The limit of x, as x approaches negative 10, is just negative 10 because you replace x with what x is approaching. Always replace x with what x is approaching first. If you do the same for problem number 58, when you replace x with 1, you get the square root of 3 minus 2. And 3 minus 2 is 1, square root of 1 is 1. Okay. And maybe over here to the left or underneath it I'll put 3 times 1 minus 2. That's the square root. And that's where we get, that's how we find the limit. Just replace x with what x is approaching. When you do the same thing for problem 59, we get the square root of 0 minus 2, so we get negative 2. Okay. Now for problem number 60, if we replace x with 1, then we see we get 0 over 0. When we get 0 over 0, what we want to do here is we want to factor. We get x squared plus 1 times x squared minus 1, and that factors x plus 1 times x minus 1. And then the x minus 1's cancel, and then we just replace x in the expression that's left over with 1. So when we replace x with 1, we get 1 plus 2. Sorry, we get 1 plus 1. Multiply that by 1 plus 1. So we get 2 times 2, and we get 4. So 4 is the limit for number 60. For number 61, running out of room here, if we replace x with negative 10, we can see that we get 0 over 0 again. So we just have to go ahead and factor the numerator. Factoring the numerator, we get x plus 10 times x minus 10. The denominator has an x plus 10 in it. When we cancel the x plus 10s, we then replace x with what x is approaching, and so the limit then is equal to negative 10 minus 10, so we get negative 20. So negative 20 is the limit for number 61. Okay. 62, we have this, let me make my red line thinner. This guy right here, if we remember the sine of x over x, that sine of x over x goes to 1 when x goes to 0. So we can just take that expression, or take that part of this expression out, and we can replace it with 1. And so what we end up getting is 9/5 times 1, or, no, that's bad, 5. 9/5 times 1, which is just 9/5. Okay, because again, that's that sine of x over x that we are supposed to memorize, that is equal to 1, the limit anyway, as x approaches 0. Okay, and then we have to do a little bit of algebra here with this, with this expression. We still want to write limit as x goes to 0, and then we're going to write 6 over 8. Oh man, I'm running out of room. What do? How about this? Let's do this. Okay, got to call an audible here. I'm not going to show every little thing, but the tangent of x, I'm going to rewrite it right here. Sine of x over cosine of x. Okay? So I'm just replacing the tangent of x with the sine of x over cosine. And then keep in mind, what did we just do? We said that the sine of x over x goes to 1, so we're going to send that to 1 when x goes to 0. And then as x goes to 0, the cosine of 0 is also 1. And so all we're left with is 6/8 times 1, which is 6/8, and I know you know that that's 3/4. So I'm just going to leave it as 6/8 because I don't have any more room. So we're going to leave it just like that. And that's it for this page.